So today we are studying CPU scheduling algorithms of operating system. So first we need to know what is a process. A process is basically a task that is now in a running state. A task is in execution. Okay. So our task is in execution when that is a process. Suppose there is a program, we have written a program, we just compile it and save it. When we save it, that is not a process. Okay, just that compile and saved it. But whenever we run that program, that is basically a process. So a program is in execution. An instance of a program, that is basically a process. So what is process scheduling? We know that process scheduling is the function of the process management. Okay, process management is a main part of operating system where basically we are scheduling different processes into our CPU. Okay, that is, it is an integral part of multi-programming applications such as operating system. But here now sometimes in some cases in our regular computers, as we know, we have only one CPU. So at a time in scheduling algorithm, we are basically allocating one process to the CPU. Okay, so which process is going to be executed next? That is scheduling main task of that scheduler. Okay, that is our scheduling algorithm. Next, so what is the basic objective of our process scheduling algorithm? So utilization of CPU at its maximum level, as we have to keep the CPU busy as much as possible to utilize it fully and get the maximum throughput. Okay, so allocation of CPU should be fair at each process. Each process of that scheduling should be fair enough. Okay, that each process can get enough amount of time to the CPU allocation. And next, the throughput should be maximum and the minimum turnaround time, and there should be a minimum waiting time. So as such that no process should be wait for the longer time. Okay, that should not happen. And throughput or minimum turnaround time. Turnaround time is basically the time taken for a process to finish its total execution time. Nextly, response time, it means that time when a process first get the signal. Okay, that is its response time. So whenever we are getting a process, we are trying to allocate that process to the CPU as early as possible. Okay, that is our response time. Next, so terminologies used in CPU scheduling. So first we need to know these terms. First is arrival time, then completion time, burst time and turnaround time. What is arrival time? When the process first arrives in the ready queue. Okay, that is, the process is ready to be executed. Means the completion time at which process completes its execution totally fully. Then the burst time, that the time required for that process to execute in the CPU. Next, our turnaround time. The difference between the completion time and arrival time is our turnaround time. That is the difference, that the turnaround time is completion time minus arrival time. Then is waiting time, the time difference between turnaround time and burst. Then last is response time. First, I have told that the time takes to respond for a request from a user process. That is the time it started its execution minus the arrival time. Next, we have different types of scheduling algorithm. First, there are two types. One is preemptive scheduling, another is non-preemptive scheduling. So, in part of non-preemptive, there are first come first serve, shortest job first, longest job first, and highest response ratio. These are the algorithms. And in the preemptive scheduling, there is priority scheduling, longest remaining job first, shortest remaining job first, and round robin. Also, then first we need to know what is preemptive scheduling, what is non-preemptive scheduling. Preemptive scheduling is basically used when a process switches from the running state to the ready state, basically in the backward direction. A process is running, but due to some interruption or some IO operation occurs or anything, or some time query expires or some higher priority process came in. These are some of the cases where a process has to switch from the ready state to the running state, and also from the waiting state to the running state, waiting state to the ready state. Basically, for the time being, that is that type of scheduling when we have to just get our process P1. Suppose our process is P1, we have to preempt that process to space to get P2, suppose, to get the space or get allocated in the CPU. Okay, so we preempt the process P1 in the middle time, then we will allocate P2. Then what is non-preemptive scheduling? Non-preemptive, as it terms refer, that we can get the full CPU allocation. Okay. Full time to get executed. Then we are just explaining the scheduling algorithms one by one. So first come first serve. This is the one type of non-preemptive scheduling algorithm. So what is its objectives or characteristics? That are jobs are going to be executed on first come first serve basis. That is, it is a non-preemptive scheduling algorithm, as we know. So when which process arrives first, that will be executed first. And easy to understand and implement, its implementation is based on FIFO-Q, that is first come first basis. First come, then it is basically poor in performance as is have to wait time is very high. We'll explain that in the next slide. So in this example, there is some process ID. Okay, in process ID, sorry, I am explaining. This is the case. Okay, so this is some process name, there is some process ID and arrival time and its bus time. Okay, so it is basically these three will be given to your question. Okay, so you need to know. Okay, you need to know the first. You are knowing that you have to draw a Gantt chart first. What you have to do? You have to draw a Gantt chart. I am drawing it. Okay. Suppose this will be your Gantt chart. Okay. So, as we said earlier, FCFS means first come first serve. So, as per the rule, there is process ID. These are the process names. This will be notified the IDs. So, P1, P2, P3, P4, P6, P5 to P6. What is its arrival time? The first arrival time is 0. At the 0th time, P1 is arrived. Okay, P1 has arrived. So we have to allocate the CPU to P1. So we are allocating CPU to P1 as its bus time is 9. So we can allocate 0 to 9 times to the P1. Okay. Then in the next, what is the next item? Next process ID is P2. In case of P2, it's arrived at time 1. Also P3 is arrived time 1. P4 is also arrived time 1. Here one of the question asked that which process should we select. Okay, which process should we select? That is, yes, there are 3 processes. So we are going to select P2 as the ID reference. Through the ID reference, P2 came first. So we are going to that schedule as the arrival time for these 3 processes is same. Okay. Then after that, we are selecting P2 for the timing of 10 at have done 0 to 9 times. Sorry, it should be 12. Okay, that is its burst time is 3. Then next P3, its burst time is 2. So then P2, P3, 12 to 14. Then P4, 14 to 18. P5, arrival time is 2. So we are gonna select it first. Then P5. Then P6 at the last, its burst time is 2. So it is gonna be 23. Okay, this is the whole case. I am going to the previous slide. Okay, so you can see that P1 is 0 to 9, then P2 from 9 to 12, then 12 to 14, 14 to 18, 18 to 21 and 21 to 23 for these are the processes. Okay. After the completion of the drawing of Gantt chart, we are going to execute or calculate these things. First, completion time. As we have already discussed, what is the completion time? When it executes the full completion of the process in the CPU. So from 0 to 9, at the time 9, P1 completes its execution. So next we are going to see that completion time of P1 is 9. So as per our Gantt chart, then the completion time of P2 is 12, P3 is 14, P4 is 18, P5 is 21, P6 is 23. Okay, completed. Then I am just erasing these things first. Okay. Then about that, next we are going to calculate the turnaround time. What is the turnaround time? We know the formula, that is completion time minus arrival time. Okay, you can get the formula, completion time minus arrival time. Okay, so turnaround time will be 9, that is 9 minus 0 will be 9, 12 minus 1 is 11, 14 minus 1 is 13, 18 minus 1 is 17, 21 minus 2 19 and 23 minus 3 20. Okay, then waiting time. What is the waiting time? As per the formula, the turnaround time, sorry, this will be the turnaround time minus burst time. Okay, turnaround time minus burst time. So 9 minus 9 0, 11 minus 3 8, 13 minus 2 11, 13 minus 17 minus 4 13, 19 minus 3 16 and 23 minus 2 will be 18. So this will be our waiting time. Then there is another term that is called response time. We have already discussed earlier, that is where the time started its execution minus this arrival. Okay. So started its execution through the Gantt chart. We can see that when it is started for P1 it is 0. Okay, so 0 minus 0 will be 0. Then it is started at the time of 9. Okay, 9 minus 1 8. Then it is started at the time of 12. 12 minus 1 11. Okay, then it is started at the time, in that case it is started at the time of 14. 14 for P4. 14 minus 1 will be 13. Okay. Next will be 18. 18 minus 2 is 16. And the last one is 21. So 21 minus 3 is 8. Okay. So these are our response time, waiting time and burst time. Okay. Completed. Then we will go into the next slide. So from there we have to calculate the average completion time, waiting time and average turnaround time. So this is the formula. These are our completion times. We have to just divide it by 6. Why 6? Because the total process is 6. So we are going to divide it with 6. This is our average completion time. Then through the average waiting time, this is 66 by 6. Our average waiting time is 11. Then this average turnaround time is 14.8. These are the cases. So next we have to know the advantage and disadvantages of FCFS. As we are using some algorithm, there should be some advantages. So that it is, as it is FCFS or first come first basis, so it is very easy to implement. Then it is first come first serve method. Okay. What is the disadvantage? It may suffer from convoy. Okay, which is the major one disadvantage. There is the average waiting time is much higher than the other algorithms, and FCM is very simple and easy to implement. Okay, that is also the case. But what is the disadvantage? The main disadvantage is convoy effect. So we are discussing it. What is convoy effect? In operating system, it is a phenomenon associated with the first come first serve basis. Okay, in which the whole operating system slows down due to few of the processes. What is that processes? Some highest burst time processes. If some processes has larger burst time, the process will get executed for larger amount of time. So the other processes that had fewer burst time than that, so it will be executed at the last. So FCFS algorithm is a non-preemptive in nature, but once CPU time has been allocated to a process and the other processes can get the CPU time only after the process has finished. It is the main character of FCFS. So this property of FCFS scheduling leads to the situation called convoy effect. That is, in that image you can see that this is a longer job. Okay, so these jobs are shorter. So if you are executing the longer job in the CPU, it takes a lot of time for that process. For that, these shorter jobs will start for a longer period of time, and these processes has to wait. Okay, these processes has to wait for longer time. I am explaining through an example. This is an example. Suppose arrival time. These are the arrival times for P1, P2, and P3, and these are the burst. So in that case, we can see that suppose I am drawing the Gantt chart. Okay, for this. Okay. First, which process arrives first? That is P3. We can see that. Okay. So we're gonna execute P3 first. Okay. As per the term FCFS. So as per the Gantt chart, as per the drawing, P3 will be executed first and from 0 to 42 times. It's a larger process. Then P1 will be executed for one time, that is 42 to 43 for P1. Then P2 just for 3 times, that is 43 to 46. Okay. So in that case, see, the completion time for P1 is 43 and P2 is 46. Okay. Then for P3 it is 42. Okay. So turnaround time as per the formula we know 42, 45 and 42. But we can see that in the formula of waiting time, that is turnaround time minus burst time, the waiting time for P3 is 0. Okay, as it doesn't have to wait. Okay, but in that case, the waiting time for P1 is 41 and P2 is 43. It has huge. So the average time, waiting time for the process will be 83 by 3. Okay, which is huge. That is, suppose if you calculate 25.8 or something. Okay, so we have to wait average 25 minutes. Okay, for this HCFS process. But I will read it later. In the next case, you can see that this is same kind of example, but P1, P2 and P3, the P1 arrives first, then P2. So arrival time of P1 and P2 is 0, so its burst time is 2 and 1. Then P1 arrives. So in that case, if we draw a Gantt chart, okay, if we draw a Gantt chart, okay, then it has to be P1 first for 0 to 2 times, okay, then the burst time of P2 will be 2 to 3 times, then the last P3 for 46, okay, okay, so it will be 46 and 45. Okay, so here we can see that we have to wait just 5 by 3 times, that is just 1 point something. So the average waiting time gets less. Okay. Next, we are explaining another algorithm, that is characteristics of SJF or shortest job first. It has some advantages and disadvantages. What is the advantage? The main advantage, it is taking based on the shortest job. It is taking or it is scheduling a particular process based on the shortest job. Okay. So it is associated with each task as a unit of time to complete. It is also a non-preemptive process, but it doesn't cause, it may cause starvation if the shorter process keeps coming. If shorter process keeps coming, then the larger process has to wait for larger amount of time. But other than that, no starvation will happen in SGL. Then this one is the example. This is the process and this is the burst. So suppose the arrival time is 0 for all the processes. Okay, so we are selecting, as I told, we are selecting as per the bus time. Okay, what is the bus time for? Here, the lowest bus time is 3 for P4. Okay, so as per P4, first it will get executed. See, 0 to 3 times P4 will get executed. P4 get executed for, and it has the shortest bus time of P3. Therefore, its waiting time, okay, will be 0 for P4. Then, what is the lowest? P1. Then, from 3 to 9, P1 gets executed. Okay. Therefore, process P1 gets executed second as it has the bus time of 6, which is larger than P4 but shorter than P2 and P3. Then, in that case, then what is shortest? As per bus time 7, P3 is shortest, which will be executed from 9 to 16 as P3 gets executed third and it has the bus time of 7, which is larger than P4 and P1. Okay. Therefore, waiting time of P3 will be 9. Okay. Then last will be P2. Process P2 gets executed last as it has the last bus time of 8. So this will be P2. So in the shortest job first, we are selecting through the bus time as which process has the lowest bus time. We will select that process first. Okay. Then the whole execution will execute it. Okay. The whole scheduling process will execute, or the schedulings or the process will be selected as per this. Then the last, what is the advantage of SJF? It reduces the average waiting time. Thus, it is better than the first come first serve scheduling algorithm. Okay, because it reduces the average waiting time because it is selecting the jobs based on the lowest bus time. Okay, then SJF is generally used for long-term scheduling. Okay, then what is the disadvantage of SJF? Disadvantage of SJF, it has starvation. It may starve. Okay, suppose shorter processes quickly came after and after, again and again shorter process came, then the longer process have to wait. Then that process may start, and many times it becomes complicated to predict the length of the upcoming CPU request, because we know that before the execution in the CPU there is a ready queue where processes are ready and waiting. So in the ready queue, it will be defect, or it will be a complicated process to just predict the upcoming length of the CPU.